we go. Alright guys, so yesterday we mainly went over proportional. Did we have any questions on the proportional stuff from yesterday? No? So what can you guys tell me about proportional? It goes to the origin. Very good. So when we're talking about proportional, there's a couple ways to tell if something is proportional. If it's proportional, then it's going to have, well, I think you guys first said it goes through the what?
Origin.
Goes through the origin. And what else? I heard somebody say it. Very good. It has a constant of proportionality.
Or slope.
Well, non-proportional stuff have slopes also. So it's not that it has a slope, it has a constant of proportionality. What do you guys remember what I mean by that? Constant of proportionality? K equals what? K equals y over x, right? That's constant of proportionality, which is very similar to what? R. Y equals mx plus b, but very similar to which variable? The m, which stands for slope, right? So today we're going to focus on non-proportional. I want you to almost think of these as opposites. So if it's non-proportional, what do you guys think? It does not go through the origin. Yeah?
Is it possible to have a non-proportional thing that does go through the origin?
No. Unless it's something that's not a line. But hold up guys, give me a second.
And the second one is does not have a constant of proportionality.
Open the back up here. Pull this out.
Really?
And you can pull this back. All the way. There's a tray that pulls it back. And then just clip them to like, you see these things? Clip them so that they only like a little part. But how about this? Go to, you know where Miss Hallwalk's class is, right?
Yeah.
Go check Miss Hallwalk's. Ask her to see her Chrome card because you're gonna help mine out. She'll let you in real quick.
Through here or?
If you want through there, or it doesn't matter. Yeah. Okay, so it does not go through the origin. And what else? It does not have a constant of proportionality. Very good. Now I heard somebody say, "Hey, proportional has a slope." Yes, you're right. Proportional does have a slope, but so does non-proportional. The only difference between it is that when you're proportional, your slope is equal to your constant of proportionality. When you're non-proportional, you don't have a constant of proportionality. You only have a slope. Does that make sense? Okay. Let me explain it to you guys right now in a graphing form. Okay. So I'm going to graph proportional. And I'm going to graph a non-proportional. Yes, please, go ahead and write this down. Okay, so to prove my point, let's start with our with our proportional, and I'm gonna draw. We'll just draw it in black. Give me a slope, guys. Give me an easy slope. 5. So that means if my slope is 5, it's gonna go through the origin, and I'm gonna go up 5. 1, 2, 3, 4, 5, and over 1. Right? Okay, so you know what? Did you guys already draw that? Okay, I just want you guys to see it a little better. So I'm gonna change this up. So I'm gonna have a slope of 1. A slope of 1, which is gonna be 1 over 1. So it's just gonna be a better example if we do it this way. Okay, so that's gonna be our graph, and I'm gonna number this, guys. So I'm gonna skip a couple lines so that it's a little bit easier to see. Now, when I'm talking about constant of proportionality, it's like talking about a unit rate, right? And if we're talking about the unit rate, I'm talking about the coordinates. So y over x. So, for example, this point right here is what? As a coordinate, this point is 2, 2. This point right here is 1, 1. This point over here is -1, -1. And this point over here is -2, -2. Everybody okay with that? Okay. So what I want you to notice is if I do y divided by x for all of these, I'm going to put it in red. So I want to find my constant of proportionality. What would be the constant of proportionality for 2, 2? It would be 1. What would be the constant of proportionality for 1, 1? 1. And for -1, -1? 1. And -2, -2, 1. So you guys all agree that the constant of proportionality is 1, right? Now let's also look at our slope, and I'm going to put that in blue. If I was to go from this point to this point, how much did I go up and over? Which would give me a slope of what? Of 1. 1 over 1, right? Same thing. If I was to go from this point to this point, I went up 1 and over 1. So with proportional, your slope is equal to your what? Constant of proportionality.
What if, so it's always 1, so even if you like went from the very bottom of -2 to +2?
Yeah, so check it out.
It'd be 4.
Exactly. It would be 4 over 4. So this is what Angel's asking. If I went all the way from this bottom point, all the way to the, give me a second, guys. All the way to the top point, it would be I went up 4 and I went over 4, and 4 over 4 is again what? It's 1. Do you guys see the pattern emerging there? Okay. Now look, I'm going to use the same slope for my non-proportional. So my slope is going to be what?
1, 1.
My slope is going to be 1, right? So I'm going to have the same slope. The only thing that I'm going to change is that I'm no longer going to go through the origin. I'm not going to go through here. So we did not go through the origin, but the points are still there. So this is 1, This is 2. This is 3. 1, 2, 3. Negative 1. Negative 2. Negative 1. Negative 2. Now I want us to look at the slope first. We said the slope was 1 over 1. So we better get 1 over 1 when we're going from one point to another. So this is our first point. This is our second point. This is our third point. We have another point there and another point here. Now count with me, guys. If I was to go from this point to this point, how far did I go up and over? So I have a slope of what? Is everybody okay with that?
Yeah.
Am I going too fast? We're good? Okay. Now if I was to do what Angel asked last time, if I was to go from the last point or the first point all the way to the last point, how far did I go up? 4, and I went over 4. Again, the slope is what? 1 over 1. So these two lines have the same slope. But now let's look at my constant of proportionality. This point right here is over 3, comma 2. If I do 2 over 3, that's 2/3, right? Is that equal to my slope?
Nope.
It's not. And not only that, but look at the other points. If I go over 2, up 1,
It's even less close.
it's not that it's less close. Yeah, you're right, it's less close, but not only is it not equal to my slope, but are the constant of proportionalities equal to each other?
No.
So it's neither equal to my slope or equal to my other ones. Does that make sense, everybody?
They're all different.
They're all different, exactly. So even though this is still a line, it still has a slope. Do you guys agree with that? But the main difference is that one has what? One has a slope that's equal to its what? Constant of proportionality, and the other one has a slope that's not equal to its constant of proportionality. And all that took was me moving the line down a little bit, or up, or whatever it's going to happen. Does that make sense, everybody?
Yeah.
Yeah?
It's like
Go.
like one of those, like a really sporadic line. No straight line.
Well, if it's not a straight line, it's not a line. Go ahead and close your Chromebooks, guys. You don't need them right now. Is everybody okay with that?
Yes.
These little clips,
They don't work?
are we supposed to clip them onto like a Chromebook card so it doesn't move?
Yeah. Move it this way, Manny. Move it this way all the way, so that way you can pull that back. Because I think if you move this forward, you can pull this back, and then you can pull the thing all the way. Does that make sense?
Yeah. So pull this?
Yeah. Pull this forward and then work back there. That way you can pull the whole thing forward. So determine if the table is proportional or non-proportional. Let's see. Hello? I'll tell her right now. You're welcome. Bye-bye. See you later, Juliana.
Bye-bye. Bye-bye. That's my job.
I need to use it from the front side. I have to put it on from the front.
Okay, yeah, go for it. Do it, however. If it's too hard, man, don't worry about it.
I don't know, it's just
Gotcha. Go ahead, guys. Determine if it's proportional or non-proportional, and then I want you to graph it. Okay? So. Graph and create the equation of the graph. Okay, I'll give you guys. I think 3 minutes should be enough. Work together, guys. Mm-hmm. Angel, you finished?
Yeah.
You graphed it and created the equation?
Oh, you need the equation.
Yeah. Yes.
The format was like y equals
Yeah.
x plus b.
So the format for it is y equals mx plus b. That's correct. By the way, if it's proportional, what is b always going to be? Very good.
Too short.
I'm curious, how did you guys start this? Anybody want to volunteer to tell us how you started it? There's a bunch of different ways. Noah, go ahead.
I started this by figuring out if there's a constant of proportionality.
Okay. So what did you get? Is there a constant of proportionality?
No.
There's not, right? So constant of proportionality. Let's see. For the first one, it would be 1 comma 3. It would be 3. For the next point, it would be 2 comma 5. Well, that's 5 over 2, and that's not equal. So this is not a constant of proportionality. So that means this has to be what? This is non-proportional. So since there's no constant of proportionality, do we still have a slope though?
Yeah.
So how do I find my slope? How do I find the slope based off of a table though?
You have to graph all the points on the table.
Well, we can do that even before. How do I find the slope without graphing it? What does the slope mean, guys? I told you it was the
Y
change in y divided by change in x. This is what I mean by that. Think of the change in y as your y values, because that's exactly what it is. And think of your change in x as your x values, because that's exactly what it is. Now look at this. What was my change from 3 to 5?
2
Plus 2, right? And from 5 to 7? And from 7 to 9? So my change in y is what? It's 2. Now let's look at my change in x. From 1 to 2 it was? And from 2 to 3, it's. And from 3 to 4, it's. So my slope is what? 2 over 1. Now look, you can also go like Angel said on the other one. Let's say I didn't want to go from one point to another. Let's say I wanted to go from 3 to 9. You guys think it's going to work?
Yep.
So if I go from 3 to 9, what's the change there? But if I went from 3 to 9, that means I went from 1 to 4. And what's the change there? 6 over 3 is also what? It's 2. Does that make sense, everybody?
Yeah.
So you can find your slope without having to graph. So I have my slope. My slope is what? 2. Can I graph this thing now? Well, what am I missing? What am I missing to graph? The y-intercept, right? Now, how can I find my y-intercept, guys? Was anybody successfully able to find the y-intercept? It's b in the equation, you're right. There are a couple ways to find the y-intercept. Okay? Do you guys want some more time to try to find it, or you guys got it? Okay, 1 second. Hello? Uh-huh. No problem. Today, I have a parent-teacher conference. Sorry. Okay. Okay. Bye. Okay, so with this one right here, there's a couple ways to do it. There's a way to do it by graphing, and there's a way to do it algebraically. I'm going to show you guys both ways. Okay, so graphically, I'm going to do it the following. I'm going to just plot my points. So my first point is over 1, and up how much? Up 2? Up 3. The next point is over 2 and up what? 5. The next point is over 3 and up 7, so somewhere over here. And I can graph that now. Go ahead, dude. Okay, so something like that. And what I can do is, look at this. How many times did I go up and over? Up 2 and over what? That's to go up on the graph. But what if I want to go down on the graph? I would go down what? Down 2 and to the what? To the left 1. What point would that be right there? 0, 1. So I can find my coordinate that way, my y-intercept that way. So you can do it that way, and then you're done with your graph, right? You're done with your equation. Your equation would be y equals what? What's my slope? 2. So 2x, and then my y-intercept is what? Plus 1. Now there's also the algebraic way. I prefer the algebraic way. I know that my equation is going to be y equals mx plus b, correct? Do I know what m is? What is m? X plus b, right? All of these values over here on our table are what kind of coordinates? They're x and y coordinates, right? So I'm just going to choose one. I'm going to choose the coordinates 1, 3. The 1 represents a what? And the 3 represents a, I'm just going to plug them into here. So it's going to be 3 equals 2 times 1 plus b. And then just solve for b. So I'm going to subtract, well, it's going to be 3 equals 2 plus b minus 2. 1 equals b. Both ways work just fine. And they'll both give you the same answer. Y equals 2x plus 1. So one of the ways to do it is by graphing it, which graphing is nice if you have a small graph, but if your graph is really big, it's not the greatest because you have to be very accurate. I Algebraic sometimes takes a little more work, but if you have really big numbers, algebraic is your best bet because you don't have to worry about being so accurate with a graph. How many guys aren't the neatest when you're graphing? Then you want to learn how to do it algebraically. If you're very neat with your graph, then you might be able to get away with finding your y-intercept with the graph. Does that make sense, everybody?
Yeah.
Do we need any more examples? We're good?